This video is going to be about a two-object kinematics problem. So it's two objects, but only one phase, and I'm going to remind you of a really cool thing you can do to check your answer when you have this kind of problem. So we have a chase. We have a chase scene. A motorcyclist is, well, it's a very slow chase, I guess. A motorcyclist is traveling behind a slow-moving tractor on Highway 25 outside of Menomonie. The motorcyclist pulls out to pass the tractor by accelerating at 3.5 meters per second squared. If the motorcyclist starts out 12 meters behind the tractor and the tractor maintains a constant speed of 45 kilometers per hour, how much time will it take to pass, and how far will the bike and the tractor have traveled in that time? And I have a little note, watch your units here. So let's see what we've got. As always, we're going to start with a picture. So we've got a motorcycle and a tractor. They're both moving, I'm just going to say, to the right. And now the motorcycle starts out behind the tractor, so I'm going to set this as my 0 point. That's my origin. I'm going to say going to the right is positive. Okay, so what else do we know? Well, we've got two objects. That means we're going to have to definitely have two different charts of variables. So what can we do? Let's do the motorcyclist first. So the motorcyclist, it was, let's see, this motorcycle was starting off 12 meters behind the tractor, and it has an acceleration. So what do we know? X initial, X final, V initial, V final, acceleration, time. All right, so they start off 12 meters behind the tractor, but I set them to be at the origin, so their initial position is 0. At some point, it's going to pass the tractor. We have an acceleration of 3.5 meters per second squared. That's about all we know for the cycle. All right, how about for the tractor? What do we know? Well, oops. The tractor starts out 12 meters ahead, so there's a 12-meter difference between these two objects, which means this thing starts at 12. X final, V initial, V final, A, T. And tractor maintains a constant speed. That should tell you right here what this number is. Constant speed, not accelerating. At 45 kilometers per hour. And that's why I said watch your units. 45 kilometers per hour. That's not the unit we need. We need meters per second. So let's do a quick conversion and see what we get. I need to convert kilometers to meters, so I want meters on top, kilometers on bottom will cancel there. 1 kilometer is 1,000 meters. And I need hours converted to seconds, so I want seconds on the bottom. Hours on top will cancel the hours on bottom there. 1 hour is 60 times 60, 3,600 seconds. So 45 times 1,000 divided by 3,600. Grab your calculator, do this, and that should give you an answer in meters per second. So go do that, and let me see what I got. My answer for the speed of the tractor was 12.5 meters per second. It's going to the right. And since there's no acceleration, we've got constant speed. Both initial and final are the same. All right. What else do we know? Well, at the point where they pass, so at some point the tractor is going to be here and the motorcycle is going to be here, and that's the point where they're passing each other. We don't know where that is. We want to know how much time it takes to get to that point, and we want to know how far each has traveled. All right. Do we know anything about the initial speed of the motorcycle? Motorcyclist traveling behind a slow-moving tractor, and then they pull out to pass. You know, I'm going to make an assumption here, but I think it's a reasonable assumption. If we have the motorcycle behind the trailer, or the tractor, I mean, and then it pulls out to pass, I'm going to say that they start off at the same speed as the tractor. So I think the motorcyclist starts off at that same one too, that same speed. I think so. I think that's a reasonable assumption to make. What else do we know? We don't know anything about time. We don't know how fast the motorcyclist is going when it eventually passes. And now there actually is, that's a common misconception that at the time when they're passing, they're going the same speed. But in order to pass someone, you can't just speed up and match their speed, because then you're just going together. No, in order to pass someone, you have to go faster than they are. So we can't assume that V final is going to be the same as any of these other numbers. So we got to be careful there. We do know that these final positions are the same. They end up at the same point. So this equals, this final position equals this final position. And we know that the time is the same between the two. We're saying that the time is the same between the two. We don't know that. All right, so how do we solve it? Well, I don't know. What do? We don't know enough to answer any of the questions we had. So let's see here. All right. Well, if I could figure out what x final is, what equation would I end up using? So for the motorcyclist, I don't know V final, and I don't know T. All right, so if I don't know V final equals V initial plus AT, two unknowns. V final squared equals V initial squared plus 2A delta x. All right, but I'm also looking for time. We know the time's the same. How about that long equation? X final equals X initial plus V initial T plus 1/2 AT squared. Is anything 0? Well, that turns out to be 0. We know that. We're looking for time and x final, and we know our acceleration. Okay. Now we know this is the same and this is the same. For the tractor, what would this equation look like? X final equals X initial plus V initial T plus 1/2 AT squared. Is anything 0 here? Acceleration is 0, so that term drops out. We're looking for this, we know this, and we're looking for time. Well, given these two equations, we actually only have two unknowns, x final, which is the same, and t, which is the same between the two. So we have two equations, two unknowns. This is solvable now, because this equals this. So what I'm going to do, there's multiple ways to solve this, but what I like to do is just slap these two equations together. This and this are equal, so this here has to equal this here. All right, I'm going to get a different color. So I'm going to put this equal to this. That's 0, so I have V initial T plus 1/2 AT squared equals this thing, which is X initial plus V initial T. Okay, can I just get rid of that? There's a V initial T on both sides. Can I? Well, the problem is that this is all about the motorcycle, and this is about the tractor. So I have to do acceleration of the motorcycle, X initial of the tractor, V initial of the tractor. I don't have to label the time because the time is the same, but I do have V initial for the motorcycle, acceleration of motorcycle, X initial tractor, V initial tractor. Okay, now let's see what we can do. At this point, I actually like to throw the numbers in just to see what I'm dealing with. V initial T, V initial motorcycle T, so that's 12.5 T plus 1/2. The acceleration of the motorcycle is 3.5 times T squared equals X initial tractor 12 plus V initial tractor 12.5 T, and then that whole term for the tractor went away because the acceleration is 0. Now in this one case, look at that. Since they started with the same velocity, these two terms will actually drop out. That's pretty rare. Don't assume that's always going to be the case. Usually we have different velocities to start with. At this point I have 1/2 of 3.5 T squared equals 12. Solvable. Half of 3.5 is 1.75 T squared equals 12. T t squared is going to equal 12 over 1.75. So t is going to equal the square root of 12 over 1.75. And if you do that, well, why don't you go grab your calculator, see what you get. What did I get? I got that the time is 2.62 seconds. All right, so the time it takes to pass is 2.62 seconds. Again, always stop and say, is it reasonable? Is it reasonable to take 2.5 seconds to pass? It's about, how far in front? It's about 30 feet in front. So a couple motorcycle lengths in front. This isn't a huge acceleration, but it's pretty good. I would say that's a reasonable time. If, again, that was 1/10 of a second, totally unreasonable. If that was 40 seconds, totally unreasonable. So I think we're in good shape. So that is one of the questions. How much time does it take to pass? It takes 2.6 seconds. Now, at this point, often the question will be done, but the next question, how far do they each travel, shows off a really cool thing about this type of problem. You can double check your answer. Now we know that the time is 2.62 seconds. 2.62 seconds. Now I'm going to keep 3 decimal points out, but I'm going to erase most of this, and I'm going to go back to these 2 equations, because the second question that was asked was, how far have they each traveled in the amount of time it takes the motorcycle to pass? Well, if we want to know how far they've traveled, we need to know where they end up. We know where they started. If we know where they end up, we know how far they went. And to get x final, I could just use this equation. The only thing I didn't know in these 2 equations was time. Now I've got the time. So let's do the motorcycle first. X final equals, that's 0, V initial, 12.5, times my time, which is 2.62, plus 1/2, acceleration is 3.5, times squared, 2.62 squared. Do that in your calculator and see what you get for the final position of the motorcycle. I should be careful here. Motorcycle. Final position of the cycle is, I got 44.8 meters. Okay, 45 meters. That's a pretty good distance. 45 meters, 150 feet. Yeah, that's pretty good. So that's the distance the motorcyclist traveled. The cool thing here is that when we solve for x final of the tractor, it had better be the same. That was the condition we set up at the very beginning. We said these 2 have to be the same. If I solve for this and I get a different answer, that means I messed up. You absolutely, for sure, know you messed up. So let's see if it's going to tell me if I messed up. X final for the tractor is x initial, 12, plus V initial t. V initial was 12.5, and our time was 2.62. Dump that in your calculator. And looky here, what do we get? But 44.8 meters. So these are the same. That's a really good sign that we did the right thing. All of our answers are reasonable, and these 2 came out to be the same, which we said they had to be. So now we can actually answer all of the questions. How much time does it take in order for the motorcyclist to pass the tractor? 2.6 seconds. And the distance traveled by the motorcyclist is that whole distance, which we said was 44.8, so about 45 meters. The distance traveled by the tractor, gotta be careful. It did not start at 0. It didn't go from 0 to 45. It went from 12. It started at 12 to 45. So we have to subtract 12 off of this. So the tractor only went 33 meters. It traveled 33 meters while the motorcyclist, which started behind, traveled 45 meters, and it took 2.6 seconds for this to happen. We've answered the question. We've made sure that the answers are reasonable. I think that's all we need to do here. So that's an example of a 2-object problem, and a good example of making sure that you use this double check method to say, hey, if these two aren't the same, I know I made a mistake and I better go back and redo it. And that, in our case, they were the same. Good sign that we got it right. All right, good job.